Okay, going over the homework answers for section 4.8. And what I'll do is I'll talk through it, and you have the answers to look at also, but I'll create answers and talk through it. So every time you have one of these problems, you've got leading coefficient times x minus a root times x minus another root, and you just keep making parentheses until you run out of roots. Now the roots that you are given are 3 and 4i. So I'm going to put in 3 and 4i. But what you have to be aware of is if 4i is a root, somebody else has to also be a root. Its conjugate must also be a root. And so I'm going to add in negative 4i is also a root. And then let me express the directions here as well. You know what? I'll deal with you blanking. I'm okay with that now. You are trying to create a polynomial function in standard form, least degree, using the given information. And then make sure to include any missing conjugate pairs, so that's the negative 4i. Least degree means don't add any more roots to it. Leading coefficient is 2, so I'm going to change this to being a 2. And then we're going to take a look at what we have. We have 2 times x minus 3, x minus 4i, and x plus 4i. Now, let me tell you that if you know what you're going to get when you multiply conjugates, you can save time. I'm going to do the full multiplication and then talk to you about how you can save time in the future if you so desire. So I've got x minus 4i multiplied by x plus 4i. When I multiply, I get x squared. I get positive 4i times x. Ooh, I get negative 4i times x. And that's the beauty of the conjugates. I'm going to finish the last box and then come back to the beauty of the conjugates. So negative 4 times 4 and I times I. Anytime you multiply a pair of conjugates, that duo will add to make 0 every single time. But I caution you, this is only when you have conjugates. The only difference is one's a subtraction, one's an addition. Everything else is identical. If you are not in this situation, don't ever do this. But in this situation, if you fully get why you can skip a step here, you can just multiply the x's together and then multiply the negative 4i and the positive 4i. You can do that because that is all we are getting when we multiply. But if you're not entirely sure that this is okay to do, go with the multiplication boxes. Make sure that you're getting everything you should always get. Now that's just looking at these two. And then we're not done because you need to not leave I squared. You want to remember that I squared is equal to negative 1. So that means that we have x squared minus 16 times negative 1 turns that into plus 16. So that's bringing together those two. Always bring the conjugates together first to save yourself a lot of other pain. Now at this point, we have a 2 and x minus 3, and we have this. You only multiply two things at a time. It doesn't matter what order you multiply in these situations. If you want to multiply the 2 into one of the two factors, you can do that. If you want to hold off, you can also do that. But understand, the mistake that I often see is that people will take this and multiply it to both of these other factors. Realize if you do that, you're actually multiplying by 2 twice. So if you do decide to multiply it, it only goes to one of the things. We multiply two things at a time always. And what I'll do is I'll just hold off on the 2 because it will be much easier to bring in later at the very end. And I'm going to multiply these two together. So as I multiply them, I've got x minus 3. And you have a choice. You can do just x squared and 16, or you can do x squared plus 0x plus 16. It's up to you if you want to do the 0 column or not. I'm going to do it here to emphasize that this allows us to keep that these two are like terms, these two are like terms, and nobody else is going to add together. But ultimately, this column is just flat out 0, so there isn't actually going to be any like terms to add together. But I want to point this out because anytime we do division, you have to deal with this. When we do division, you're going to have to deal with possibly making a column that is actually 0 times x, or 0 times x squared. And if you don't make that column, you're going to be really messed up with what you're supposed to create. So multiplying, we have x squared times x, negative 3 times x squared, 16 times x, and then multiplying, let's see, that's going to be 3 times 15 is 45, and then another 3, 48. And there we go. There are no like terms to add together. If you want, you can get these, and they're just 0x squared and 0x. Not going to do anything. I have 2 times x cubed, and I'm going to write it in descending order. So next I'm going to put the x squared, and then the x, and then the constant. And then I'm multiplying the 2 through at the very end, because that means I have smaller numbers that I'm multiplying when it's more complicated. And let's see, 32, and then 100 minus 4, 96. There we go. And then there it is. So that's number 1. With number 2, do you need me to just keep going through all of these? Okay.
Ms. Blanchard,
yes. Yes.
So how come you only, oh, never mind, sorry. On the answer key,
I
just need, like,
did I accidentally do something different?
Yeah, I was just confused.
Oh, my silliness. Do you see my silliness in the answer? I have to fix it. I started distributing the 2 and then stopped. So you get to see that it is so common that that's why you should check your work after a test. Yeah, I am going to have to fix that, and then I'll re-upload the correct answers, provided that I remember to do that. The only way I'm going to remember to do that is if I open it right now. So, and that was homework answers for 4-8. Okay. All right. Then number 2. There we go. See, I knew you'd come back to me. Still better than Chrome. To point out to you, you've got x-intercept, 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 but this is y-intercept. When you create your polynomials, you have a leading term, leading coefficient multiplied by x minus a root, or a 0 if you prefer, or an x-intercept if you prefer. The x-intercepts are the roots. They are the zeros. So I have 3 of them. So I have x minus 2, x minus negative 3 turns into x plus 3, and x minus 1. This y-intercept, I will need to use that to find my leading coefficient. And if I want, I can find it right now. So this is what my polynomial, let me change the color on that. This is what my polynomial is equal to. So this says if I plug 0 into x, my polynomial will equal 1. And if I plug in 0, I'm going to get a negative 2, a positive 3, and a negative 1, multiplying to that c. And then that becomes positive 6, divide by that positive 6, and then you have your c. So I'm going to write it out as we've got 1 over 6 times these 3. From there, it's a matter of going through the multiplication. Do you need to see the multiplication? So that's a yes. Okay, I've got a yes online. So pick any 2 of these at a time. So let's see. How about I do these 2 first? I don't know if that's what I did in the answers, but just know that you don't have to multiply in the same order as I have on the answer key, but you can only pick 2 at a time. And my advice is wait on this 1/6 and multiply it through at the very end. All right, then multiplying those 2, I have x squared minus x plus 3x minus 3. And this becomes, add like terms together. And now I'm going to bring back the fact that I still have to multiply by 1/6 and x minus 2. And then following that theme of I can only multiply 2 things at a time, I'm going to multiply my parentheses. And so I have x minus 2. One thing that I love is that I have a lasso. Boom. And I can scoot that down because I did not make enough room. Oh, I love the full version. Google Chrome can go somewhere else. Alrighty, I've got the x squared plus 2x minus 3. and then multiplying x cubed, negative 2x squared, positive 2x squared, negative 4x, negative 3x, positive 6. My like terms are nicely diagonal. And now I can see that when I multiply all this together, I'm getting my leading term x cubed. When I add my 2x squared and my negative 2x squared, I get 0x squared. Very nice. Then when I add my x's together, I get negative 7x. And finally, the lone constant plus 6. I'm now going to take this and I'm going to bring it up. Oh, it didn't bring the other part of the x with it. I can deal with that. And now this is the result of multiplying those two. And now I can multiply the 1/6 all the way through. And I've got my polynomial. Okay. Now, let's take a quick look at how much more I need to go over with you. Did that just write itself funny? I'm trying to think about time-wise, how much should I go through? Would you say that I need to go through this graph? Do you need me to go through the graphing thing? Yeah. Yes. I have a request for number 5. Wait, where did that go? Oh, wait, do I even have a number 5? Okay, I messed up somewhere. So I had a number 5 in what I printed, but not here. Okay, so I think I might have messed up, and let me find that. I named the packet COVID because I had to break it up into smaller pieces. Okay, let me see where I put the homework. So there's 4. Oh, no, there we go. Wait, on the packets you have a number 5?
No.
Oh, okay. So that was an issue. Okay. I probably corrected that issue, but then it was, I see the confusion. There was no number 5. There we go. That's official now. Probably what happened was I took it out, and then that other thing added to being confusing. Okay. So also 3 at the end of the problem printed far away from the rest of the equation, so I didn't see it. Okay, that's all right if you didn't see it because I messed up on how I printed it out. My fault, not yours. Just make sure with your corrections that you do the problems. Do you need to see 3 or 4 done? And let me add on, after what I've gone through with 1 and 2, do you feel like you still need to see one or both of these done? What? Number 4. It's so much harder to hear with the masks. Okay, so I have a request for number 4. And then also, so that's fine. If you accidentally didn't do number 3 or didn't do 4 because you didn't see it, I won't mark you down for that. But again, the corrections, make sure you have it. Okay, for number 4, we have the leading coefficient is 5. So automatically, I'm just going to put a 5 in front, and then it's going to be x minus for as many times as I need. But that's more times than I need, because my roots are 4 with a multiplicity of 1. I don't need to write this one, but I'm just emphasizing it. And then a root -2 with a multiplicity of 2. And that's it, so I don't need this next parentheses. So this is my polynomial. From here, it is just a matter of multiplication. And do you want to see the multiplication? Or are we ready to move on to 6? Hand. So hand, yes. Go ahead. I'm listening. Oh, accident. Oh my goodness. Online is just amusing. I know you don't treasure this right now, but sometime in the future, you're going to look back at this and go, that was really unique. It sucked, but I can tell people about it. In the future, when you have kids or you know some kids, you can be like, oh yeah, you know what I had to go through? Ha ha. So you shut up. I get to do that when it comes to looking things up in the library at my time. Do your parents do that to you? They're like, you don't know how easy you have it. You can just Google search. We had to go through the card catalog at the library after driving there. So that's our joy of sharing our pain. And here we go, multiplication. And by the way, did you ask for this multiplication? I just realized that I just didn't get a response on that. Oh, yeah, the card catalog, yeah. You know what, I'm starting, so I might as well just keep going. Okay, adding like terms for this, I have x squared plus 4x plus 4. I'm going to next multiply the x minus 4 with it. I didn't need to write the plus, but whatever. And then I have x cubed, 4x squared, negative 4x. Oh, yeah. I love it when they cancel each other out. Don't you? So adding like terms, that's going to be 0. But I've got an x cubed, a minus 12x, and a minus 16. The only thing I have left to do is distribute the multiplication of 5 through, and I'm going to leave that for you to finish. Okay, this one. So if you know one of the factors, you can use division to help you find out what the other roots are. If this is a known factor, realize that you know right then and there that positive 3, if I decide to use this as 3, positive 3 is an x-intercept. Now, I don't know necessarily whether that's going to be a multiple root yet or not, because I need to go through the division. So going through the division of x minus 3, I know that inside I need to create this polynomial. So I'm going to put the leading term in the upper left corner, and then we get going. From here, x times 2x squared will give me that 2x cubed. Continue the multiplication by knowing that. And then the next big step is this plus its diagonal must make negative 7x squared. So that means I need to add a negative x squared. Then x times what is negative x squared. And then do the remaining multiplication of positive 3x. And then these diagonal boxes will add together to make positive 2x. And we can see that that means I need to subtract x from 3x. Then I figure out that I need to multiply x by negative 1 to get the negative x. Continue the multiplication. And then that completes the polynomial, and I have no remainder. Know that if you find a remainder when you were told that this was a known factor, that your arithmetic went wrong somewhere, and you've got to go find it. So what this gives me is, while x minus 3 is one of my known factors, it needs to multiply to a 2x squared minus x minus 1 to give me the full polynomial. I'm keeping the x minus 3 factor that I already know, and then I'm taking this quadratic and I'm going to factor that quadratic. And do you want me to talk through the factoring slowly? Okay. So I'm going to start with the diamond. And the diamond is a times c, 2 times negative 1. And then the b is negative 1. Two numbers that multiply to make negative 2. And let's see, negative 2 and positive 1 multiply to make negative 2. They also add to make negative 1, so that's my winning pair of numbers. But all that does is tell me how to split that piece up. I'm trying to factor the polynomial that has a 2x squared. Its constant term is a minus 1. And the negative x is broken up as a negative 2x and a positive 1x. Then I want to look down this column, but I can pick either column 1, column 2, row 1, row 2, whichever one you prefer to start with. And you want to look at factoring, what could factor completely out of both terms? What will divide both of them? 2 will divide both of them, and x will divide both of them. So if that 2x is what I need there, it needs to multiply by x to get me the 2x squared, and it needs to multiply by negative 1 to get me the negative 2x. Then I move over to this box and see that I need to find what multiplies to x to make x, and that also multiplies to negative 1 to make negative 1. So I've actually got my factorization right there, 2x plus 1 and x minus 1. So once you have that factored form, you're now ready to determine the roots and the multiplicity of the roots. Now, I started off knowing one of the roots was 3, but now that I've factored completely, I know that's multiplicity 1. 2x plus 1 will equal 0 when x is equal to negative 1/2. And that is also a multiplicity of 1. And then positive 1 makes the third factor equal to 0, and it is also a multiplicity of 1. What I'm going to do is I'm going to put on here, I've got 3 already. Negative 1/2 could go here. And then one, I've got my 3 x-intercepts. I know that I will slice through each of them. And I messed up here, as you can see. So the x-intercepts are what we just found. The y-intercept is when I plug 0 into all of my x's, and this is easiest in the expanded form. I can see that 3 is my y-intercept. So I'm going to plot that point as well. Now, to look at the degree, the leading coefficient and the degree, it is easier to see in the expanded form, which is what I was given to begin with. And if you look at the entire leading term, the largest exponent is 3. That means this is degree 3, leading coefficient is positive 2. And when it comes to end behavior, I personally prefer drawing. No, dear. Calm down. Ooh. Okay. I personally prefer drawing my end behavior. This is a formality of, I know you need to be able to read what this means if you keep going with your math classes. But what I personally like to do is just look at, okay, leading coefficient is positive, right end goes up. The degree is odd, left end does the opposite. And I can see visually exactly what I need to see to graph my polynomial. As a formality, this says the left end, and the left end goes down, so that's negative infinity. This says the right end goes up, and so that means positive infinity. You can write just infinity, or you can write positive infinity. It's up to you. But what I really need to get out of that is the end behavior, and I'm going to bring that into play. And I'm going to show you that there is only so much I expect you to be able to do as you are graphing. Because this is all multiplicity 1, I am going to just ninja slice across the x-axis. And so I can see that I'm starting from below, so if I go left to right, I'm going to hit this point first and then this point. So I'm going to be coming up, slice, hit that point. I do not expect you to know how high this goes. I just expect you to realize that the next thing that you're aware of is that it will slice through the next x-intercept. I don't expect you to know how low this goes. I just expect you to know that it's next going to have to come back up in order to slice through that x-intercept. On the answer key, I have the official graph, but know that this is as much as I'm looking for when I look at your graphs. I'm going to show you the actual graph. And that does not have to be exactly correct. The only thing that has to be correct is x-intercept, 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 and the fact that it's a slice. Y-intercept has to be plotted, and then the end behavior needs to fit. And other than that, it's connect those with a pretty wavy graph. Okay, so I need to get onto the classwork for today. Are we ready? All right. I have 20 minutes now. Okay, so I'm gonna try to fly through some of the stuff that you can later just take the time to think about. The remainder theorem, that's what in 2 homeworks before, I had something that prepped you for this. Basically, this is all you need to understand. This is the remainder if you divide by x minus c. The remainder, when you divide by x minus c, happens to be the y value if c is plugged in. The only thing that really is important to you at this point is that that leads to the factor theorem. This is what I really want you to know. If P of C is equal to 0, so if you find a number that you can plug into X and you get 0, you know that what you have is a factor X minus that C, and that is a factor of that polynomial. And further, that makes C a root of the polynomial as well. So let's start some examples. If you are told one root and you're asked to find the other roots, you're going to realize that you need to take the polynomial and you need to divide it by x minus that root. So we're going to do polynomial division. Yay! That's what you said in your mind, right? Haha, haha. I don't know anyone that says yay. Maybe there's someone who does. Actually, I kind of do, but yeah, whatever. All right, I am supposed to be getting in the interior boxes first a 2x cubed, and then my 3x squared is what I'm going to get between those 2 boxes added together. My negative 9x, I will get with these 2 boxes together. And then if this is a root, then this has to be negative 10 when I get there. If it isn't, this problem either lied to me or I did something wrong. That's if you know that it has to be a root. So now, let's do the rest of the division process with this understanding. When I do the division process, I am looking at what goes here. X times what is 2x cubed? And so that's 2x squared. 2x squared times 1 allows me to know what goes here. And then I need to add to make 3x squared. I've got to add a 1x squared to my 2x squared. Then I continue on. I need to figure out what goes here. X times what is x squared? And that would be x. Then I multiply it to the 1. And then I'm ready to make negative 9x. And I can only do that if I subtract 10x from my positive 1x. And then, hopefully this will work out, x times what is negative 10x? And does that allow me to get that negative 10 there? Yes. Woo! So I'm going to find my other 2 roots through this quadratic. And I'm going to factor this quadratic. And by the way, if it's not factorable, guess who you have to turn to? Quadratic formula. Because we're just trying to solve for what makes this equal to 0. If it doesn't factor, quadratic formula is going to be the one to come into play. And I'll go through the diamond method of 2 times negative 10. And the b number is positive 1. I need to find 2 numbers that multiply to make negative 20, add to make a positive 1. And hopefully it doesn't take you too long to see that that's going to be a positive 5 times a negative 4. That tells me how to break up the preparation. So 2x squared and the constant, and then that leftover x is found by doing a 5x and a negative 4x adding together. For this particular box, I'm going to look down the column and see what can divide both. X is the only thing that's going to divide both. And there is another order you can go about this. This isn't the only order to attack. Then, if this is x, this is going to have to be 2x to multiply to make 2x squared. And if this is x, then this is going to have to be 5 to multiply to make 5x. And we're actually close to done. Now I look over here at this negative 4x. 2x times what? Negative 2 will give me that. And then 5 times negative 2 is negative 10. Woohoo! Factored. So I have a 2x plus 5 and an x minus 2. The other roots are just solving this equation being equal to 0. So 2x plus 5 equals 0 and x minus 2 equals 0. Subtract the 5, divide by 2, and over here just add 2. And now I have the other two roots. Bada-boom, bada-boom. And I'll make an official answer of it. Ah, you adorable little computer and your glitchiness. At least you're not a Chromebook. Man, after yesterday, I'm just so happy with this. I have found that when I use the school computers, they have a harder time with the school's Wi-Fi. I don't know why. Or at least it appears to be that way. All right. Next example, same thing again. And how much time do I have left? I still have 13 minutes, correct? I keep asking because I forget what time each class ends. All right. If I have a, yes?
I was saying, like, this class is really tiny. Wow, we're almost done.
You mean with the hour?
Yeah.
Yeah. We're supposed to have an hour and a half. This is, you know what? Let me just keep going and not complain about what I wish we had, because we don't. So x minus negative 2 is a factor if negative 2 is a root. To find the other two roots, I'm going to have to go through division again. See if you can stay ahead of me this time. I'm going to do my prep work. I am doing division, so my 5x cubed has to be in the upper left box. And then I can actually prep this and take a moment to go, these two will add together to make a positive 5x squared. These two will add together to make a negative 7x. And if I don't have a remainder, which I'm not supposed to have, then this last box must show up as a positive 6. So let the process begin. X times a 5x squared will give me this box. 5x squared times 2. And then I need to add these diagonally to get a positive 5x squared. So I'm going to have to take away 5x squared from 10x squared to get that. Then x times a negative 5x will give me that negative 5x squared. And there's my 10-minute warning. Negative 5x times 2 gives me a negative 10x. And these two boxes have to add to make a negative 7x. So I need to actually add 3x to the negative 10x to get the negative 7x. And then finally, x times 3 will give me 3x. 3 times 2 is 6. Woo! Yes, the green matches. We needed that. That means that the polynomial can be factored as an x plus 2 times the quotient alone. 5x squared minus 5x plus 3. But to find the other two roots, I need to factor further. I can always quadratic formula if I want. With factoring further, I know that I'm looking for 5 times 3 is 15. And then negative 5 is my middle coefficient. So I'm looking for two numbers that multiply to make positive 15, but when I add them, I get a negative 5. That doesn't sound like something that we can do, does it? Are we forced into quadratic formula? What? Oh dear. We are forced into quadratic formula. So, when you learned quadratic formula, did you learn the song with it? Some of you did. Did you do the Pop Goes the Weasel song or another one? Ah. Okay, I will remind you of your quadratic formula. We are trying to solve for this polynomial being equal to 0. And if you have an ax squared plus bx plus c equals 0, the solution to that equation is, drum roll, and here comes the, thank you. And then here it comes. If this will cooperate. No, it's not cooperating. You know, the drum roll and then sad. Okay. X equals negative b plus or minus the square root of b squared minus 4ac. And I'm thinking you sang it in your head, all over 2a. And I know you shouldn't feel comfortable singing. No, you could, you might, but in a class of 7 people and you're all teenagers, I would be surprised if any of you sang. I would claim you to be an extreme extrovert if you did. And a show off on top of that. The person who loves attention. Okay, so this is your quadratic formula. What?
Voice superiority here.
What?
It's all self-explanatory. You're trying to maintain your voice superiority over all the students.
I'm trying to maintain my voice superiority.
You must maintain your singing status.
Oh yeah, because my singing status is way up there. Unfortunately, when you're sitting in the classroom, you can't hear what they're saying. But then again, it goes the other way too. All right, so looking at the time, I'm going to just head straight over here. And I want to point out to you that we end up getting a negative number under the square root. Anytime you're doing quadratic formula and you have a negative number under the square root, the first thing always that you will do is make that negative 1 inside the square root become I outside the square root, and then the positive number is left in the square root. And the square root of 35 cannot be simplified in square as far as square roots are concerned. So there you go. Those are your other two roots. Woo! Now, let's see how much I can get done in 6 minutes. Because I think, yes.
When it says 5x squared minus 5x plus 3, so why is it a positive? I mean, why is it more than 5 and not a positive 5 on the
Okay, let me see real quick. Let me go back over here. Did I mess that up? It's possible. It happens to me. Negative b should be positive 5. I messed up. Did everyone online, did any of you see that actually? And you were about to tell me? Or maybe you just probably didn't want to do math. Okay, so now I have another thing that I need to remember to fix. And that was the classwork answers. I'm opening that document so I don't forget that I need to fix it. Okay. So, now, there's a tiny bit left to go over with you, and it's mostly vocabulary words. So, with having only so much time left, these are pretty straightforward vocabulary words, but I'm supposed to make sure you are aware of them. I'm going to just go straight to the answers. I think that's going to get us through this with the amount of time we have left. A graph is considered to be increasing, which means the function is increasing if when you go left to right, you are heading upward. So you are always thinking left to right. So if I'm going left to right, I am heading upward, so I am increasing. Then I am heading downward, so I am decreasing. And then I change and I am increasing because I'm heading up. So it's about heading upward or downward from left to right. A relative maximum, it pretty much says itself. A relative maximum is a high point on the graph, and it's a place where the function changes from increasing to decreasing. A relative minimum is a low point on the graph, and it is where the function changes from decreasing to increasing. You can abbreviate them by Rmax, Rmin. And then, oh, I didn't change that from wiggles to inflection point. Wiggles was a description, but inflection point is mathematical. So, when it comes to what is the least degree of a polynomial, we have already started to look at this. The number of minimums and maximums, your least degree is one larger than the number of minimums and maximums. So I'm going to come over here and I'm going to point out on number 4, we have a relative maximum, a relative minimum, and a relative maximum. There are 3 of them. Add 1, minimum degree is 4. But when I go to look at number 3, do you see that I've got this relative minimum, but over here, I just have this inflection point? What you want to know is an inflection point that doesn't form a relative minimum maximum, which is actually kind of why I add the word wiggle in there, because it's an issue of it's wiggling without creating the maximum minimum. So I drew this progressive look of from, oh, it just kind of barely wiggles, to, ooh, it's trying to kind of pull. And what I imagine is, and one of these days I'm going to find something to do this, you can pinch and stretch. I'm going to keep talking because the recording is going to keep going and you can watch the end if you have to go. Leave your nameplates so I'm able to take attendance, because know that that is right now the only way I'm going to take attendance. And it's like I'm grabbing onto those points and pulling them. You too. So when you have this kind of wiggle without a relative minimum maximum changing, it actually counts as a relative maximum and a relative minimum. So it counts for two things when you see that wiggling occur. And here's a nice little formula if you like. But what you're looking at is that you have a relative minimum, and this wiggling causes to add 2 to that 1. And so in a way, you have 3 relative maximums minimums. That makes it degree 4. This one has a relative maximum, a relative minimum, a relative maximum, a relative minimum, and then a wiggling. And that wiggle counts for 1 maximum and 1 minimum. So that's 2, 4, and then 6. Go up 1, that's your minimum degree. So that's the rule in dealing with these. And I'm going to go back to the formula. I put W as number of wiggles, but it's not a mathematical definition, but it's a description of something trying to create that minimum maximum. So to find the minimum degree, what you're doing is you're counting the number of minimums, maximums, and pretending that a wiggle was an attempt to create another minimum maximum pair, but it failed. So it counts as 1 minimum and 1 maximum. So basically, R stands for the number of relative minimums plus the relative maximums. If W is every wiggle you see, double it because it is counting for 1 apiece, a minimum and a maximum. And then add 1, and that's going to be your minimum degree. And now let's look at these last ones. I have a relative maximum and a wiggly bit. So that's going to be 1, 2, 3, plus 1 is 4. Over here, I have a relative minimum, relative maximum. Now, do you see that it's slicing? If you look right in the middle, it's slicing through 0. It's not wiggling through. So that's not going to add to the count. So I have 1, 2, 3, 4. 4 relative minimums and maximums, add 1, 5. And then with this one, I have 1 minimum, 1 maximum, and 1 minimum. I can see that this is a wiggly thing, but that's the only wiggly piece. So that means I'm going to count 1, 2, 3, 4, 5, plus 1 is 6. You should also notice that you know the difference between the graph of an odd degree versus an even degree. Make sure that if the ends go in the same direction, like 6, that you have an even minimum degree. And 8 does that as well. But if the ends go in opposite directions, you should have an odd degree as your minimum degree. And that's it. For those of you still here, let's see, I got to end my recording.